Today we're going to talk about chemical reactions. Specifically, by the end of the lesson, you should be able to do these two things. You should be able to write formulas for diatomic elements, and I will explain what I mean by formula and diatomic element in a moment. The second thing that you should be able to do by the end of the lesson today is write a formula equation when given a word equation. So I'm going to give you some words, and you're going to turn it into symbols and numbers. Okay, so the rest of this video is going to show you how to do that. First, what is a chemical equation? It is an equation that represents a chemical reaction. So you've seen, pictures of beakers with stuff in them, and say you start mixing things together. A chemical equation just represents the reaction that's happening there, that chemical reaction. And a chemical equation always has this format. You have an arrow in the middle, and everything that's written on the left side of the arrow are the reactants, and everything that's written on the right side of the arrow are the products. The reactants, that's what you begin with, and the products, that's what you end with. That arrow, when reading it, you can say yields. So it's these reactants yield these products. Okay, and if you have multiple reactants, like you're mixing more than one thing together, you put a plus sign in between the reactants. And the same thing goes with the products. If you make more than one thing, then you just put a plus sign between those products. Okay, now common forms of chemical reactions. So this is going to have that same sort of structure that I just told you about, where the reactants are written on the left side of the arrow and the products are written on the right side of the arrow. There's three basic types of reactions. We'll talk about some more later, but the first is this one. A plus B yields C. A and B are on the left side of the arrow. So in this case, A and B would be my reactants, and C is a product. Here's another type of reaction that can happen. A yields B plus C. So I start with A, that's my reactant, and it breaks down into two things, B and C. Those are my products. Another type of reaction is I take two things, A and B, and I put them together, and this yields two new things, C and D. So A and B would be my reactants, and C and D would be my products. Okay. Now, chemical equations can be written in two ways. You can write them as word equations, or you can write them as formula equations. Word equations are just what they sound like. They're only words there. There's no symbols, there's no numbers, just words. Formula equations, on the other hand, those have symbols and numbers in them. And formula equations can be balanced or unbalanced. And we'll talk in another video about how to balance equations. In this video, I just want to teach you how to go from a word equation into a formula equation. Okay, so here's an example of a word equation. This has that format that we saw a second ago, where I take A plus B, and that yields something new. Okay, so you have iron plus oxygen yields iron 3 oxide. The 3 there, those are Roman numerals. Now, if you were asked to turn this word equation into a formula equation, you could do that by looking up the symbols for each of these on the periodic table. So you would go to the periodic table, find iron, and you would see that there's a symbol for iron. The symbol for iron is Fe. Okay. And when you look up oxygen on the periodic table, you see that the symbol for oxygen is O. So that's where this O comes from. And then iron oxide, you just put the Fe and the O together. Now, you may be wondering, where do these little symbols that I see, like the little S and G and these little twos, where's that stuff coming from? So that's what I want to go to next. But before we do that, before I explain how to figure out what those little numbers are, this is what the equation would look like once it's balanced. So you will, over the next couple of lessons, get pretty good at going from a word equation, like you see on top, into a formula equation. Right now, I want to show you step by step exactly what you need to do to go from word equation into formula equation. So those symbols that you saw, they mean certain things. So the little S, when it's written, that just means that that substance is solid. If you see a little L beside the substance, then that means it's a liquid. If you see a little G, that means it's a gas. Aqueous just means that you can dissolve that substance in water. If you put it in water, it will dissolve. That's what aqueous means. If you see an arrow going in both directions, that means that it's a reversible reaction. So those reactants can make the products, and you can swap places. The stuff on the right side of the arrow can make the stuff on the left side of the arrow. That's if it's reversible. If you see a little triangle over the arrow or just the word heat, that means that reaction requires heat. So it has to be heated up for that reaction to happen. And then if you see a little PT over an arrow, that means that you have to add a catalyst, which is something that speeds up a reaction. Okay, now all that was just kind of like an introduction to word equations, formula equations. Now I actually want to show you step by step how to go from word equation into formula equation. The very first thing you need to figure out when you're looking at a word equation, ask yourself this question: is the substance that you're looking at in that equation, is the substance an element that you can look up on the periodic table? And if it is, then you need to figure out whether that element is monatomic or diatomic. Monatomic means it's just one atom there. There's only one thing there. And if it is monatomic, then you can just write the symbol that you see on the periodic table. So here's an example. If I saw the word sodium in my word equation, I would go to the periodic table. Sodium is an element on the periodic table, and the symbol for sodium is Na. So I would just write Na. And then I've begun my formula equation now. However, there are some elements on the periodic table that are what you call diatomic. That means that you don't find them as just one atom. Rather, it's like two atoms together, but the atoms are identical. Okay, so it's like having two of the same thing stuck together. Now, there's a specific column on the periodic table that that is diatomic. So if you find column number or group number 17, you'll see Br and I and Cl and so on. These are diatomic elements. So when you write, if you saw the word, I didn't say this, but diatomic, the di just means two. Okay, there's two of it. So here's an example. If I saw in my word equation the word bromine, I would go to the periodic table and I'd see, oh, bromine is in that list. You need to know the list here of diatomic elements. Bromine's in that list. of elements that are diatomic. So if I see the word bromine, I know I need to write a little 2 beside it because it's diatomic. You don't find just one bromine all by itself. Rather, you find 2 bromines stuck together. Okay, so that's the very first step in going from a word equation to a formula equation. Ask yourself, is this word that I'm looking at in the word equation, is that an element on the periodic table? And if it is that element monatomic or is it diatomic? If it's monatomic, you can just write the symbol exactly as it appears on the periodic table. If it's diatomic, then you write the symbol and you put a little 2 beside it. Hydrogen would be another example. If I had a word equation that had the word hydrogen in it, then I would write the symbol H and put the little 2 next to it because hydrogen is diatomic. Okay, that's step 1. Step 2 in going from a word equation to a formula equation is to ask yourself if the word that you're looking at, if that substance is a compound. A compound means it's made out of more than one element, and the elements are going to be different. Okay, so if it's an ionic compound, that means that it's made out of a metal and a nonmetal. So it's made out of more than one element, and the elements are different. One is a metal, one is a nonmetal. If it's a molecular compound, then, I'll say molecular in a moment. So let's stick with ionic for now. If it is an ionic compound, so it's made out of a metal and a nonmetal, you have to balance the charges. So for example, if in my word equation, if I see these 2 words, calcium chloride, and there's no plus sign separating them, those words are together. Okay, calcium chloride. There's no plus sign in between them. It's just 2 words together, calcium chloride. Then I would look on my periodic table and I would see calcium is a metal and chlorine is a nonmetal. So I know this thing is ionic. If it's ionic, then I need to balance the charges. Calcium is in group 2, so calcium has a plus 2 charge. Chlorine is in group 17, and anything in group 17 has a minus 1 charge. Notice these charges aren't balanced. Plus 2 is, you're trying to cancel the charges out. So you have a plus 2 on the one hand and a minus 1. What can you do to balance those? Well, if you have 2 chlorines, not just one, then when you put together a minus 1 and a minus 1, that adds up to a minus 2. That can cancel out a plus 2. So that's how you get the charges to cancel. Okay, that's if it's ionic. So the formula then would be Ca, Cl with a little 2 beside it. Now let's talk about molecular compounds. So molecular compounds are 2 nonmetals put together. When you're dealing with molecular compounds, you have to use prefixes based on the subscripts that you have. So here's an example. If I see dinitrogen tetraoxide, the di in front of nitrogen is a prefix, and the tetra in front of oxide is a prefix. Di means 2, so that means there's 2 nitrogens, and the tetra means 4, so that means there's 4 oxygens. So if I saw the word equation, dinitrogen tetraoxide, I'm going to convert that into a formula by using nitrogen as the N, oxide is the O. The di in front of the nitrogen tells me there's 2 N's, and the tetra in front of the oxide tells me there's 4 O's. So that's N2O4 is the formula equation that I would write. Okay, so those are the basic steps of how you go from a word equation into a formula equation. Now, in a separate video, I'm going to work some examples for you.